Hello and welcome to this session on sustainable aviation fuels. My name is Alejandro Block. I'm a senior technologist at the Aerospace Technology Institute. And it really is a great pleasure for me to present this paper on the integration of sustainable aviation fuels into the air transport system. Before I get started, I want to thank all the contributors that participated in this work. So it is me presenting, but it is the work of a lot of people and a lot of organizations. So a big thanks to everyone that made this happen. It was a great job. So sincere thanks on behalf of myself, the Aerospace Technology Institute, and the Airport Council International, who is our partner in this publication. So a quick introduction to our SAF paper. I think when we talk about decarbonizing aviation, we're always talking about the importance of collaboration. And I think that this is a really good example of that, where Airport Council International, an organization that represents over 2,000 airports around the world, and the Aerospace Technology Institute in the UK that funds aircraft technology research and development, came together to produce this paper. So the content on the paper is based on 11 interviews to different professionals from the industry, on 53 documents that include airport feasibility studies, infrastructure studies, scientific peer-reviewed publications, and industrial publications. We had the participation from 35 professionals from 10 different countries. And these professionals participated in the shape of interviews. They read the paper, they helped us to draft it, they gave us information, they corrected some of the things we wrote, so big participation here. All up, that's 19 organizations collaborating and working together towards that one objective. So doing all of this took us more than a year to complete. So it is quite a comprehensive work from a lot of people, and we really do hope that you enjoy reading it. A little background to this report. On 2021, the beginning of 2021, ATI published their white paper on sustainable energy sources for aviation. And this is an airport's perspective of what airports could be facing when dealing with different energy sources at the airport. That means electric aircraft, hydrogen aircraft, or aircraft powered by SAF. As a follow-on from that, we decided to expand on each one of these topics. So the partnership was created between Airport Council International and the Aerospace Technology Institute to look into these aspects more in detail. So our first publication on the integration of hydrogen aircraft into the air transport system was created. And this was, again, a view from the airport perspective of what needs to happen to enable hydrogen aircraft into the airport. The natural step from there was to do the same, but for SAF. We often say SAF is a drop-in fuel. It's easy, and it can be used. It can be deployed using existing infrastructure. So we really wanted to understand that and see what are the limitations, what are the challenges, and what are the opportunities. And this is how this paper was born. In addition to that, I want to highlight the document on the bottom of the screen. That is our Destination Zero, the ATI's 2022 technology strategy. This document sets the direction for research and technology of the UK. And in that paper, we created this chart that you see on the screen. So that is the one possible pathway to achieving net zero emissions, and that's the pathway that we have published in the ATI strategy. As you can see, the different pathways to decarbonize the industry takes us through more efficient aircraft, zero carbon aircraft, better operations, etc. But a large proportion of that is sustainable aviation fuels. Now we see that even if hydrogen aircraft came in service today, it would still take decades for those aircraft to penetrate the fleet and to completely replace our existing fleet. So the best way to decarbonize the existing fleet of aircraft is to fill them up with a fuel that is carbon neutral or near carbon neutral, like SAF. Now, the reality is that today we only use about less than 0.1 million tons of SAF today. And when we look at this chart, we will require more than 470 million tons of SAF by 2050 if we are to follow this pathway. So that represents a big challenge. And we really wanted to understand how can we take SAF production, distribution, etc., from these individual initiatives that we see today to a full supply chain that can actually decarbonize aviation. So what do we have inside the SAF paper? I've already mentioned some of the things that we have, but I've selected a few other topics here. So first we start with the basics. What are the differences between SAF and CAF? and SAF being sustainable aviation fuel, CAF being conventional aviation fuels. So we went back to the chemical properties and said, why are these substances different? How are the emissions achieved? How can we scale it up? Then, as I moved towards the right of the screen, we looked at the blending limit. So why do we need to blend it? If we're saying SAF is a drop-in, then why do we need to blend? And how can we enable 100% SAF? That is from an aircraft technology perspective, but also from an infrastructure perspective and a supply chain perspective. We have seen individual initiatives that have flown aircraft on 100% SAF. So why can't this happen today with commercial aircraft flying passengers all around the world? What are the challenges that we need to overcome? Now, to the bottom left, we have non-CO2 emissions. So we're aware that SAF, because of its different chemical composition, has some advantages on non-CO2 emissions. So what do this mean? And what these benefits are, not only for climate change, but also for airports and for airport local air quality. How can we quantify them? What are the gaps that we still have? Moving on to the last bit, we have supply chains. So today, SAF has been facilitated at airports in individual initiatives with supply chains that have worked and are tailored for those initiatives. But when we look at scaling that up and we look at 470 million tons of SAF, those supply chains might not work. So what we look at is 3 different implementation periods and how can supply chains change from the initiatives we have today to full scaled up supply of SAF to airports. We also looked at the blending requirement and how can the blending point move as the supply chains evolve and as the volumes increase. So this is a quick overview of some of the contents of the paper. Of course, a lot more detail is going to be covered inside and further in the panel. Just to conclude on some of our main points, the main conclusion is, of course, SAF is key to reduce carbon footprint of existing and upcoming aircraft. There is no doubt about that. We will require SAF as being one of the many solutions to be able to drive emissions down to 0. 100% SAF today is not a drop-in fuel in its blending. This creates a level of complexity. It creates changes in the supply chain, but we need to continue working towards solving those challenges and towards deploying 100% SAF. We looked at 3 different stages of implementation for the supply chain: initial facilitation, early ramp-up, and a full-on scale-up. So in the paper, we looked at the different infrastructure and supply chain requirements for each one of them. A lot of experience has already been gained by certain airports and airlines. As I said, there are initiatives today, and we will hear from some of those airports in the following panel. So there's a lot of experience there, and we encourage airports that are not experienced to read our paper and to communicate to the more experienced airports, because a lot of knowledge can be gained by talking and by capitalizing on the experience of other people. We also identify that barriers still exist and must be quickly overcome. For example, the 100% SAF barrier. That's a technological barrier that has a solution, but we need to speed it up. Another barrier commonly spoken about is the price of SAF. There is still a big price gap between kerosene and SAF. How are we going to close that gap? How are we going to encourage airlines to use more SAF? And some others. So with that, I would like to conclude this presentation. I thank you for the attention, and we'll move on to the next session. Thank you, and welcome to this panel on sustainable aviation fuels. Now, I'm very happy, and we're very lucky to have with us 4 excellent presenters, experts on their field, and contributors to the paper as well. So welcome to the panel, and let me introduce you. We'll start with Juliana Scavuzzi. She's the Senior Director of Sustainability, Environmental Protection, and Legal Affairs at ATI. Juliana, thank you so much, and welcome to the panel.
Thank you so much, Alejandro, and thanks for the ATI for the partnership and for launching this paper. We're very excited about that. Thank you.
Thank you. Next, we welcome Denise Pronk. She's the Program Manager for Corporate Responsibility at Schiphol Airport. Denise, thank you so much for logging in, and thank you for the support for the paper. Welcome to the panel.
Thank you, Alejandro, and thanks for inviting me to this panel.
Next up, we have Erin Cooke joining us from the US. She's the Sustainability Director of San Francisco International Airport. Thank you so much, Erin, for joining us, and again for the contributions.
Thank you, Alejandro, and to ATI. Excited to talk through what we learned today.
Thank you. And closer from where I am, we have Toby Wells. He's the Future Fuels Technology Leader for Airbus. Toby, welcome, and also thanking you and Airbus for the contributions to the paper. Welcome to the panel.
You're welcome, and thanks for the invite, and looking forward to a really interesting discussion today.
Thank you. So let's get started. And again, before I start, just thanking you all for the contributions to that paper. I think we learned a lot through your experience. So a big thanks. And I will start with Juliana. Juliana, ACI is the main partner in this work. And as the partner of the publication, would you be able to tell us why is SAF important for ACI and why is this important for your members?
Absolutely, Alejandro. Thank you for the question. Well, for airports, there is a limitation on how much they can reduce emissions based on their own scope 1 and 2. So the opportunity to support with the reduction of aviation emissions is quite relevant for them as well. So that's where we started to look into sustainable alternative source of energy. And we started a partnership with ATI on hydrogen, and now is the time for this SAF paper. So we do see that airports can become facilitators in this process of early up and also at the scale up period. So we hope that we can contribute to that and make the membership aware of how they can also be helpful and support in this regard.
Thank you, Juliana. Yeah, so I'm going to move a little bit away from the paper per se and go a little bit into the content. And this question is directed to you, Toby, from Airbus. So we, just before on the presentation, I mentioned about the necessity to blend fuels and the differences between 100% SAF and blended SAF. Now, I mean, we often hear that SAF is a drop-in fuel, but then we hear that we need to blend it, and there's a blending limit. So would you be able to tell us a little bit about that, and why do we need to blend fuels? Why can't we just put 100% SAF on an airplane?
Yeah, it's a great question. Obviously, we all want to be able to go as far as we can with the SAF limits and push it up to 100%. But right now, we do have to put in place certain limits. And the technical reason behind that is that the quality and the composition of the fuel is really key for the safe operation of the aircraft. It's one of the few things on any aircraft that doesn't have any redundancy, right? The same fuel goes to both the engines or all of the engines on an aircraft. So it has to be right to ensure that the aircraft can work properly. So, and when we look at the SAFs that are produced using different techniques, clearly from the traditional fossil fuels, some of those properties, the chemical properties, go outside of the normal range that the aircraft and the engines were designed for. So what we do is put in place these limits so that once the SAF is blended with a fossil fuel, it comes back within that range of experience. And what's particularly challenging is that once SAF is blended and we decide we can call it drop-in, then it can end up anywhere in the fuel system. It could end up anywhere on an airport going to any type of aircraft because it's just considered jet fuel. So if we want to label something as drop-in, we have to be confident that it not only works on our most brand new latest A350, but also that it will work on the oldest A300 or any other aircraft that's out there in the world. So that's what makes it particularly challenging.
Yeah, thank you, Toby. Yeah, that's very, very interesting. And from a technology perspective, I mean, you mentioned, okay, we need to blend, we need to make sure that the chemical properties are the same. But we hear a lot about Airbus trying to enable, and Boeing as well, trying to enable aircraft to fly on 100% SAF. So what exactly are the technical challenges and what are the aircraft manufacturers doing to be able to support this?
So there are many, probably too many to list right now, because the fuel has a lot more functions on board the aircraft, many more than just powering the engines. But some of the top ones for us are the fuel gauging system, which is what allows the aircraft to accurately, well, allows the pilots to accurately know exactly how much fuel is available on the aircraft. We've noticed a few discrepancies with that when we're pushing SAF really to the limits, so we need to make sure we can tell exactly how much fuel is on board. We have materials compatibility challenges. So particularly with things like O-ring seals and elastomer seals, which are making sure that fuel doesn't leak out of pipes, equipment, engines, that kind of thing, and get to somewhere where it might cause a fire risk. We need to make sure we've got the right compatibility with those materials. On the engine side, we're looking at the overall, what we call the operability envelope. So not just how the engine performs in the steady state during a cruise when you're going along quite happily, but also what happens in abnormal conditions. What happens if you have to restart the engine during a flight when you're at high altitude and it's nice and cold, or any of those kind of conditions which we don't see on a day-to-day basis, but we can see at some points, and we need to be able to handle them for safety. Then there are some other challenges which we already have a solution for. So people often mention lubricity when it comes to SAF. So the fuel is used to lubricate some of the components that it goes through in the aircraft and the engine. But actually, we already know that we can address this through additives, so adding small components to the fuel itself to increase its lubricity. So that's less of a challenge. In terms of how we're addressing this, we've been testing with SAF across all of our range, really, both on newer engine designs and older ones, just to gain this experience. And we're currently assessing what does it mean when we go to 100% SAF, what changes might we have to make, or what limitations can we put in place just to make sure that we have that safe operation.
Excellent. Thank you, Toby. That's very well articulated, and I'm sure that we're all learning a lot from what you're saying. Thank you. So now we're talking about right now we use SAF and we blend it and we potentially move to 100% SAF. But I would like to hear, Erin, from you. You're coming from San Francisco Airport. You have a lot of experience in dealing with SAF. So I have two questions for you. One is, does SAF arrive to San Francisco blended, or does it arrive neat, and do you blend it on site? How does it work today? And perhaps you can share with us a little bit about how has your SAF supply chain changed over time from the first flight up until today, because I'm sure you have a very interesting story to tell here.
Yeah, absolutely. Thanks again for the chance to share a bit more of our journey in using sustainable aviation fuel at San Francisco International Airport. So I may answer the second question first, more in covering the longitudinal history of SAF deliveries. But so what we started with in 2018, Singapore Airlines, as a demonstration and commitment to their 40th anniversary, decided they wanted to deliver sustainable aviation fuel to SFO. Luckily, prior to that, in 2017, we had already put in place a SAF working group to really explore what it would take to grow and scale sustainable aviation fuel use at our airport. But we really didn't have the chance to operationalize it yet. So this for us was a chance to really kind of explore what it would look like with their model, which was actually uplifting directly to aircraft. So naturally, the fuel did come in blended via tanker truck. This gave us kind of the chance to look at the opportunity to really deal in the most complex delivery environment. One, obviously, that's not preferred by airports due to the disruption in service, but worked well for us just because of these long haul flights have longer turnaround time and longer dwell time. So the benefit of us doing this was that we really had the ability to onboard our airfield safety and fire teams, knowing that SAF was truly drop-in and blended to a 1655 spec when it was being, again, uplifted into the aircraft. So in terms of handling it from a fire safety and life risk perspective, no change. So gave them a level of satisfaction. From here, we were able to really grow our deliveries over the rack with our fuel farm that's operated by our fuel consortium. This for us, again, also arrived blended. It was tankered in from Southern California from World Energy at the time. And this gave us another stepping stone in really gaining support across all of our partner airlines to drop SAF into our on-airport hydrant system. We had tremendous leadership by our airport fuel consortium director at the time, who issued a statement to all airlines noting the safety of this SAF to, again, a blended to a 1655 spec. And now SFO is actually receiving the highest volume of SAF that we predict currently of any airport in the world. We're expected to receive nearly 12 million blended gallons of SAF this coming year. And this has actually been during peak COVID. So our percentage volume mix is actually higher than we anticipated. We were targeting a 5% SAF target by actually the end of next year. So we're really thrilled by this growth. And the deliveries that have been enabled by Lufthansa, Alaska, JetBlue, American, Amazon, DHL, Delta, and actually Signature, who have all committed to using SAF from two producers, Neste and World Energy, who again produces in Southern California. Neste for us is doing this with our conventional fueling infrastructure that's upstream of our campus to limit the transportation emissions associated with its deliveries. We think that this really is the model for drop-in fuel, and have allowed our airport to, and actually our airlines, to step closer to our ambition of achieving zero carbon, because obviously for airports, the landing and takeoff and taxiing is just such a high percentage of the emissions represented in Scope 3. So 99% of all emissions generated at SFO. So we're really thrilled with this movement, and really glad that Neste can deliver, again, in our East Bay, bring in a cross bay pipeline into our hydrant system, and then distribute to all aircraft. So we say that, we used to say that all aircraft have about a molecule of fuel. I think they may be getting more of a gallon now, and we're looking forward to it being a higher percentage in the near future.
Thank you, and that is very inspiring, and I'm sure that a lot of our people watching will really appreciate learning from your experience. And I can draw there some three very distinctive phases, right? So bringing a tanker in and then pouring the SAF onto the fuel farm with your offloading racks, and now you're taking the SAF into the external fuel farm, into a pipeline, and then into the airport. So that is excellent and very good progress. Congratulations on that. Now we have another airport here, Denise, from your perspective, Schiphol Airport. I know that Schiphol has a very leading role in trying to reach net zero for Europe. So I would like to hear a little bit about the activities that you're doing, and we were talking about some just before, how you're helping to deliver SAF and to tackle some of the challenges that we have identified when we wrote the paper.
Yeah, thank you, and happy to share our experiences. So yeah, as you already said, we committed to the net zero carbon goal for the aviation sector already in 2018. And if you commit to a goal for Scope 3 emission, we felt the responsibility that we also should take action in the entire supply chain or the value chain to reduce those emissions. So we investigated what our role as an airport operator could be in this global aviation sector. And yeah, our conclusions were that we could be active in the policy field, that we could really contribute in shaping national and international policies. So we did that via ACI, of course, but also via the World Economic Forum, where we are one of the founders of the Clean Skies for Tomorrow platform. That has really done a lot of work for feedstocks and plants, and also policy setting in Europe. So that was one part. And the second conclusion was, of course, that there is hardly any SAF available. So we decided that we should stimulate or financially contribute to the development of SAF plants. So we did that for one SAF plant in the Netherlands for the development phase. That is often a phase that is hard for startups to get money. And for us as an airport operator, it was relatively easy to finance this development phase of the plant. And we invest in research and development for e-fuels in the future, because we think we need not only the biofuel SAF, but also the e-fuels and hydrogen. It's an end-to-end strategy. And you already referred to it. What we introduced this year is a financial incentive for airlines. If they uptake sustainable aviation fuels from Schiphol Airport, then they get a financial contribution for SAF. And if they experiment with e-fuels, the financial contribution is even higher. so that we could really stimulate the R&D in that part, for that part as well. So I think that's in short what we are doing.
Yeah, in short in time, but not in short in depth, I'm sure. It's very impressive and very inspiring to see airports getting involved with the supply of fuels, investing in the development of fuels and giving incentives to airlines. That's really good. So I guess one of the things that come to mind, I mean, we're talking about financial investments and helping airlines bridge that gap. So I would like to hear a little bit more, I mean, I guess from both Erin and Denise, in terms of what mechanisms are you using or can be leveraged to help airlines uptake higher blend rates and cover that price premium, which is still quite large. Whoever wants to go for, maybe I will go with Erin and then with Denise. Although Denise, you've partially covered it, but maybe you want to say a little bit more. Yeah.
Yeah, I mean, I think obviously right now conventional fuels still reign king economically, and unfortunately have not been given as dynamic a suite of policy incentives as have on-road fuels, particularly in the United States, obviously the market I'm most familiar with. And we feel that that certainly should be at least made equivalent, if not certainly exceeded, because on-road transportation has the ability to electrify, whereas certainly aircraft for the long haul flights that SFO serves primarily are not there yet and don't expect to be for several decades. So we're doing certainly a suite of things. I would add on to what Denise shared around the World Economic Forum. SFO in 2018 actually completed a financing study that looked at what type of mechanisms we should be able to pursue that could really help SAF meet price parity. And kind of the discovery for us was that there really isn't a great deal of monetization that's happening right now with the co-benefits of SAF use that really are achieved on airport. That for us, benefit our 8,000 airfield workers and all of our surrounding communities, which are the reduction in SOx and particulate matter. There are a lot of wonderful incentives that exist for that. Even our Federal Aviation Administration has a cost effectiveness factor on the reduction in the criteria air pollutants and air quality benefits that are derived from using on-ground fuels, and yet don't yet allow us to include those for using sustainable aviation fuel. That for us in the United States is due to the fact that we do not procure fuel as airports. We're in fact prevented from doing so, which is quite challenging, particularly when airports are really leading in this space and would like to engage more in that monetization mechanism. And so I would say, part of our research and producing that paper was to try to establish that as an interest point for airports to inflect and get more engaged in that market, and socializing that certainly up the ladder. We've had some really actually great progress with the Department of Energy kind of accordingly to that right now. So we're really thrilled. And I think that's also been kind of an outgrowth of some of the work of the World Economic Forum and the Sustainable Aviation Buyers Alliance that is looking to, not just create additional incentives for the carbon intensity reduction that's already been claimed by our airlines or their corporate investors, but seeing if corporates actually also want to make good on the criteria air pollutant and, again, net community benefits that are served from the uplift of fuel. Beyond that, I could probably talk for the next 45 minutes about all the incentives that we're trying to play into, but I would just certainly give kudos to California, which really is the market leader in creating incentives because we do have the low carbon fuel standard that went into effect in 2019. It's why the uplift of fuel, sustainable aviation fuel, is so much higher in California. We're currently providing about $1.25 more per gallon than any other market in the world, maybe to be outpaced by Schiphol. So we'll wait to see on that. But it's been, just obviously an incredible opportunity to really get more fuel here, and I think to make the market really shift this way in terms of commercialization and seeing that there is at least a stable incentive that's in place. Beyond that, sticking with California, we still feel like There are other countries that are starting to outpace us, as I just noted, both in terms of new incentive structures, but also the rise of EU mandates. And so SFO and a consortium of airlines and SAF producers are lobbying the California legislature through AB 1322 to create a new roadmap for increasing SAF incentives. To really just try to maintain our competitiveness and leadership. So would recommend taking a look at that. And then very lastly, at a federal level, we have two representatives, Schneider and Kildee, and also Brownlee, that have introduced the Sustainable Skies Act, which is trying to create a new tax credit that's aimed at incentivizing the production of low carbon sustainable aviation fuel for SAF that achieves a 50% or greater reduction in life cycle benefits. And the tax credit could be another $1.50 to $2 per gallon if you can get up to that 100% GHG emission reduction, which some of our SAF producers are actually doing. So really thrilled that there is this tiering effect that's occurring. It's really what we need to do to commercialize and grow the SAF fuels. As Denise mentioned, there is just such a deficit in the volume, and the demands are growing. But we need to get these fuels to market, and we need to get them to uplift an aircraft as soon as possible, particularly given that the IPCC says we need to peak emissions by 2025. The time is now.
Thank you. Yeah, wow, it's quite a lot of things. And I'd like to pick on 2 points that you made to divert to Toby and Juliana. But before that, I want to hear from Denise and see how are the mechanisms similar or different in Europe and specifically in your airport to what we've heard from Erin.
Yeah, it's probably good to mention that the European Commission has published the Fit for 55 proposal last year. And one element, or the aim of this Fit for 55 proposal is to reduce emissions with 55% by 2030 for the entire European Union. And one of the elements is the Refuel EU proposal, and that's about a blending mandate for aviation. The proposal was 5% by 2030 and ramping up towards the net zero carbon goal in 2050. But there is still some lobbying and negotiation going on. So we hope that this percentage for 2030 will be increased. So that's not sure yet. And to come back to our financial incentive, it runs from 22 till 2025. And then the blending mandate kicks in 2025. So the market should be ready to provide SAF themselves. But then, of course, we're thinking about some alternative incentives to award airlines that take off more than the 5% that they should do according to the European Commission. So there are some elements we can play with to further stimulate airlines. But also a focus on only e-fuels could be an option, of course. Yeah, we really have to work that out for the future.
Yeah, thank you, Denise. So we have two complementary approaches. So in Europe, we're seeing the mandate, and then Schiphol Airport doing an effort to try to bridge that gap to get us to the level that we need for the beginning of the mandate. And then in North America, we have the low carbon fuel standard and incentives to producers and airlines. So very interesting. So as I said, I want to pick on 2 points, but I'll go with Juliana first. I mean, clearly this is very important, and it's very impressive and inspiring steps. But we're talking about Europe, North America. Together, this is about a bit less than half of the world's traffic, right? What about the rest of the regions, and how can we incentivize the whole world to be aligned? I mean, when we look at all the decarbonization pathways, we're talking about hundreds of millions of tons of SAF, which will have to be deployed all around the world. So how do you think we can work with other regions in the world to try to have the same level of incentives?
Thank you, Alejandro, for the question, and thanks to Erin and Denise for pointing such exceptional examples. That really shows the leadership of some airports. But as you say, Alejandro, we need also to look beyond and in other regions. that's part of what we're trying to do with the paper, right? Trying to provide like awareness and examples on where they can start. So this is one element of the raising awareness and the educational piece. So if they have an interest to engage on that, we give some sort of a step-by-step process, or they should start familiarizing themselves. So for airports, they don't have the technical knowledge, the operator itself, they don't have the technical knowledge and understanding on the regular fuel or the blended SAF CAF elements. So this is quite important. They need to work in collaboration with a broad range of stakeholders, which is something beyond we have done in the past within and outside the aviation sector. And we have seen also Erin mentioning part of the test flights that she had, the examples that served as a way to making the ecosystem more confident that this could happen and this could be made in safety requirements. But apart from that, I think it would be quite relevant that you look into different aspects if you want to scale up at the global level. So for me, and because of my expertise and how we work at ACI, I think I'll point to policy, because we also have seen those different types of policies from two regions, which I feel they're complementary. But at some point, you need to understand other regional approach. For instance, if they have different types of feedstock, so the feedstock availability, at different regions, how we're going to have, some consistency at the global level in terms of the development of those policies. So I'm really concerned about, the unintended impacts of good intentions. We're all trying to do something. This is a first of a kind. So we need to be cautious on trying to look into that. So those policies need to be flexible to kind of be reevaluated and adapt to change, and to bring I would say, the wider regions and different types of maturity in terms of emission reductions. We need to scale up infrastructure availability as well, that will be able to provide that SAF, because we cannot continue with just looking to specific points where the SAF is produced and then they're shipped to faraway locations. So engaging the regions in their opportunities to actually produce SAF locally and understand how this can be scaled up, it's quite relevant. And from policy, as I said, we need to work together. The level of collaboration we need to achieve is quite challenging, I would say, because we cannot compete on this. This is something that, although we have seen a trend of competition on the environmental compliance and elements, this is something that we need to understand, that we cannot do this alone, and we need everyone to be on board. I would say so. Appropriate policy, look into this, how to engage in local and regional other types of possibilities of production, supply chains, but at the same time look into the policies and the collaboration on the right way.
Thank you, Juliana. And I think you've highlighted some very important points there, and there's a little bit of that on the paper about trying to simplify the supply chain, not only from a cost perspective but also from an environmental perspective. We don't want to be moving things around the world. We prefer to have things more locally. So that's a really, really good point. Thank you for that. And then another thing that you've mentioned, and it was mentioned as well by Erin, are the sort of wider environmental benefits, right? So Erin, you spoke about quantifying or monetizing the non-CO2 effects, which is very interesting. Of course, the impact of aviation goes beyond CO2. We have non-CO2 effects, we have contrails, we have different substances at the airport level, which you all know very well. So now, Toby, you've been quiet there in the corner, but I want to bring you in here to tell us a little bit about the non-CO2 effects of SAF. And you mentioned before the different chemical composition of SAF and what we call on the paper CAF, conventional aviation fuel. So if these substances are a bit different, when we burn them, we expect the combustion products to be a little bit different as well. What could be the co-benefits and what are the differences?
Yeah, you're quite right. So we understand really well, I think, the CO2 benefits that we can get from SAF. That's what it's known for, and we know we can get this, 50 to 80% with a bio-based SAF, and maybe going even further with the move to e-fuels on the CO2 life cycle. And equally, on the climate front, we understand to a really quite high degree of precision the effect that CO2 has on the climate. Whereas when we looked at the non-CO2 effects, it's a lot more uncertain, I would say. We know there's an impact, but we don't quite know how to quantify it just yet. So what we do know is that many of the types of SAF, because there are lots of them, not SAF is not just one thing, but many of the types of SAF can offer us big benefits far beyond just the CO2. In essence, the SAFs are cleaner burning because most of them contain no sulfur at all. So you don't get any sulfur oxide emissions. And in addition, most of them are low in aromatics, and aromatics is a particular type of hydrocarbon that's in the fuel, which leads to quite a lot of production of particulate matter. So if we remove the aromatics, we can drastically reduce the particulate matter. And both of these things have an impact at local level around the airport on the air quality. So removing them and reducing those emissions can give us additional benefits there. Then on top of that, particularly in the case of the particulate matter emissions, there's a link with the production of contrails. It's considered that that these particulate emissions are what lead to contrails which form and then stay. That's the most important thing with contrails, is that they have an impact on the climate when they stay in place. They stay up there as a cloud. So if we can reduce those contrails, we can reduce our impact on the climate. And to reduce the contrails, we need to reduce the particulate emissions, which we can do using SAF. But just, to really stress that the science has so much more uncertainty in this regard than on CO2. So, and it's a much more complicated, I would say, a chain of events that happen towards that impact on the climate that we really need to understand at each step. And Airbus has been working with partners in the UK, in Europe, and across the world on this to do our bit to fill in the gaps in the science and reduce that uncertainty. And we're doing that so we can focus our efforts in the right place to make sure we can really reduce our climate impact as much as possible. So you might have seen in the news recently, we've been flying our aircraft on 100% SAF as well as on conventional fuels as well. And we've actually been chasing that aircraft with a small plane following directly behind its emissions, because that's up there in the sky is the only place you can really get a true sense of what emissions your aircraft is going to give you. That's where you get the accurate data. And it's taking a long time to kind of develop this science, but we're now at a point where we can start to make decisions very soon based off the results that we're seeing there.
Excellent, thank you, Toby. And I wonder in which airplane you were flying, on the one at the back or at the one burning the SAF?
I tell you what, I would not have wanted to be on board the one behind,
Exactly.
which was a Dassault Falcon, which is a 1970s French business jet. And was specifically chosen because it is a very robust construction, as in it was quite a heavy aircraft for its size. But 50 meters behind an Airbus A350 is not a pleasant place to be flying another aircraft.
That would have been a bumpy ride, I suppose. But if you go and download our report, we do have a really nice picture of that event that was courtesy of Airbus. So we do have it there on the report, so available for everyone. So now, of course, these co-benefits of SAF, they depend on how much SAF we have on the blend, right? So Erin, you were talking going from a few molecules to a few gallons. Now, some of the research that we read, so that when the SAF concentrations are very small, these co-benefits are small. You know, if I fill an airplane with a small blend, and this sort of plays into trying to increase the blend of SAF to take us to 100%. So I'm going back to the first question that I asked Toby: what can we do to have 100% on an aircraft? Now, what about airports? Are airports ready to receive 100% SAF? Is there something that we need to do to be able to adapt this? And how fast are we moving towards that objective? That's an open question for anyone that wants to chip in. Yeah. Erin, do you want to?
I mean, I guess I would say airports and airlines, need to be connected in our partnership, and we're not ready until our airlines are ready. Obviously, you're talking more from an infrastructure perspective, and I think we've certainly shown that there can be a phased approach to bringing in higher volumes of SAF. So if it means bringing, unblended fuel in and uplifting directly to the aircraft because, there's more phasing needed on the infrastructure, fine. All our fuel consortiums and certainly public safety professionals need to know is that it has been certified to a certain specification through ASTM. So once that's achieved, we're ready to go. Obviously, it takes support and partnership on behalf of the OEMs and the airlines in order to get there. But I think we're certainly learning a lot about what it means to have higher blend limits and higher blend rates at our campus, going from, again, a few hundred barrels to now thousands, hundreds of thousands of barrels. We think our refueling infrastructure can certainly handle it and is ready for those higher volumes. Once again, we can get SAF closer to cost parity and commercialize and scale the volumes to enable to achieve that.
Yeah, thank you.
Maybe
yeah.
to add from a technical perspective, in the kind of OEM industry at the moment, we're considering actually two routes to 100% SAF, which are known as drop-in and non-drop-in. But maybe non-drop-in should be called nearly drop-in or something like that, because we're not talking about something that's crazily different to the existing fuel. And Airbus is really pushing for both of these approaches in parallel, because the drop-in 100% SAF will be something, like I mentioned earlier, that really fits into the existing known envelope of properties. And Erin mentioned the need to be able to drop this straight into the airport infrastructure as easily as possible. So with this drop-in pathway, we'll be able to do that. We'll be able to have a fuel that's fully certified for any aircraft across the whole world, up to 100%, and we'll be able to drop it into the infrastructure, and you might not even know that you're using that fuel on your aircraft. It may be that someone else has paid for it. Then perhaps for the slightly longer term, we're also looking at this non-drop-in or nearly drop-in, which is where we can push the limits on compatibility, but also to get some benefits for the environment, for the local environment, for the climate as well. That does then present the challenge that we might not be compatible with every aircraft that's out there in the world. So we have to understand the best way to make sure that the right fuel gets to the right aircraft. We don't know exactly what that looks like yet. Does it mean segregation of supply at airports, which I know would be a huge challenge, or is it some lighter measure? Is it the different sized fuel nozzles like you have at the petrol station for petrol and diesel? We don't know, and we're weighing up those challenges against obviously the benefits that we can get from that. But it's a bit early to say. But certainly the drop-in fuel is coming soon, and it will be fully certified and approved by all the OEMs across the industry at 100%.
Excellent. Thank you, Toby, for that. And I think it's very important point you made between making that differentiation, right, of like sort of fully formulated and then sort of paraffinic SAF, if you like. And there are more details about that on the paper as well. So yeah. We're running out of time. We have about 5 minutes left. So it's a shame because I think we can all talk about this for hours. But I would like to ask and emphasize again the fact that our objective here is to decarbonize the industry, right? So we want to hit net zero. We want to do that as soon as we can. We know that SAF is one of the pillars to be able to achieve that. So how do we go from the sort of 0.1 million tons to the 400, 500 million tons of SAF? And what are our main challenges? What would be the main lever that we can pull to be able to achieve that? So I would like to go around the table, maybe starting with Juliana, and then Denise, Toby, and then finalizing with Erin. So.
Sure, Alejandro. I will choose some points because I'm pretty sure my colleagues will want to touch upon others. But just coming back on the point of the drop-in at this stage, just to let everyone know, our position is that it should arrive drop-in at the airport to minimize the requirement of infrastructure. But yes, we need a lot of things to make the scale-up process. But I'd like to point again to two things. which I think they're both big challenge, but also big enablers, which is collaboration and policy. So that collaboration aspect, because we really need to re-educate ourselves in the type of collaboration we need to work on, and test and include innovation, innovative ways of collaborate, understanding the challenge we have, understanding that we are trying to assess what would be the barriers for scaling up, but we still are not there. So I still like to think about still early process things that we're looking at right now are still are going to be continued relevant aspects like feedstocks, energy requirements, use of water, land on the production side, but also infrastructure, supply chains, and so on. And on the policy side, as I said, we need to make sure that we are responsive, and even we may be able to anticipate those challenges and be flexible enough at the same time. But I agree. I think that an international framework could facilitate a common level playing field at some point where some consistency and some flexibility could be addressed. Things to be discussed, and I guess this is just food for thought for the others to kind of complement. Thank you.
Thank you, Juliana. And Denise?
Yeah, to add to that is that I think that we should really take into account that while we're ramping up the SAF production, SAF stays sustainable, because there are so many feedstocks that can be used, but as aviation sector, we should really be aware of that risk, and that is very important for us to work with real sustainable aviation fuels. So I think that's important to mention. We also did a collaboration with NGOs and airlines 2 years ago here in Europe. It was a great partnership, all serving the same goal and intention. So that was really nice to do. And I think we already mentioned it, but the policies in other regions in the world are very important to avoid carbon leakage, because that's my main concern. That while North America and Europe are working on those decarbonization, passengers choose routes, passing by Europe or North America, and therefore, could lead to carbon leakage. So that's a very important topic we should work on as an entire ecosystem, because no one can do it on its own, of course. So I think those are my two important takeaways.
No, excellent, Denise, and thank you for raising that up. I think it's extremely important points. So thank you so much. Yeah. Over to you, Toby.
Thanks. Yeah, and I mean, I'm a technical guy rather than a policy or an economics expert. What I do know is that technical compatibility at the moment is not a blocking point, and we're working hard to make sure that is never the case. We always want to be ahead of the curve. So, right now as we've said, we can take up to 50% blends, and the best airport in the world is at 5%. So we've got some headroom, but we'll make sure we're ahead of that curve. In terms of the scale up and the production, it does seem to me, and maybe it's just a feeling, but it feels like we're at a turning point. The demand for SAF is now really outstripping the supply. I know just anecdotally, Airbus has been trying to buy SAF, and some of our partners have been trying to buy SAF this year, and we simply cannot buy it because all the production capacity is accounted for. But right now I can count on my hands the number of SAF plants that are producing at a large scale, and that really needs to change. We have a huge number of plants which are in the pipeline and coming online maybe in the next 5 years. So I think that that supply is coming, but it's definitely lagging behind. So for me, if we can ramp up the funding to kickstart that production and start help businesses with maybe the capital funding to be able to build the plants, and then once we've got the momentum, the economies of scale will come. But I think we really are at a turning point right now.
Thank you, Toby. Yeah, again, excellent, and thank you so much for those insights. Yeah, I'm going to move now to Erin just for the last remarks. Thank you.
Great. Yeah, I guess I would say, 3+ and adding these, because I certainly agree with all the points of the other panelists. Something we've been trying to really harness and maybe focus on just as a layer over what was discussed already is, really trying to tap into and build the economic development benefits as a driver for state and national investment beyond what's already occurring. We feel like for the renewable energy industry, and then certainly for the renewable diesel industry, that those have kind of long been the platform through which renewable fuels have been able to enter the market, and to do so much more competitively over obviously a heavily subsidized fossil industry. And so we think that there really is the promise of harnessing job growth, job opportunities, and giving some foresight and insight into the fuel transitions that need to happen that Juliana spoke about at the top of the hour. So we in the United States use so much renewable diesel, but at least in California, we have this heavy emphasis on decarbonizing the ground transport market, all the way up through having a ban on combustion vehicles sold for single occupancy use after 2030, and then a clean trucking requirement that's going to basically move and shift that renewable diesel supply to somewhere. And the rational location is sustainable aviation fuel, but the endurance of our SAF producers to be able to undergo permit review, inspections, the things that are really required in order to make those fuel conversions of those plants is quite significant. So I think I'd like to see the economic development, business community come together and figure out a rapid permitting pathway for those, retrofits of facilities and or new commercialization of facilities, allow them to scale as opposed to being a barrier. Not asking for certainly any waivers of environmental review. Those are absolutely essential for maintaining the sustainability and safeguarding our communities, but that I think there could be some creativity in the way that we permitted other industries to apply there. Again, I have lots of other ideas, but that would maybe be my add-on for now.
Okay, well, that was great, and that was a very interesting session. I hope that you're all as inspired as I am. And of course, I want to thank the 4 presenters that were here, and they are 4 out of the 35 contributors to this paper. I wish we could have had all 35 of them presenting here, but that would have been a really long panel. But thank you so much for our presenters to be here. Thank you for the audience, and we'll wrap it up here. Thank you.